Today's class, I will teach you how to find current and voltage as a function of time by using Laplace Transform technique. I have written a problem on the board. We have to find V naught of t. Assume zero initial conditions. So we have been given a circuit having R, L and C components. There is no initial voltage across the capacitor. There is no initial current through the inductor. We are supposed to find what is V naught of t. Okay. Solution. The Laplace transform network. The Laplace transform network is as shown below. The Laplace transform network is as shown below. Laplace transform of u of t. Laplace transform of u of t is 1 by s. We have derived this in the last class. Laplace transform of u of t is 1 by s. Resistor will not change once you apply Laplace transforms. C will become what? C will become 1 by Cs followed by a voltage source which is Vc of what the voltage across the capacitor is Vc of 0 divided by S. Let us assume this is the current through the branch. The current has to enter the plus terminal. I have told this in the last class. 5 ohm resistor will not change upon taking Laplace transforms. Inductor will become what? L into S, and initial current to inductor will give a voltage source which is L into IL of 0. It will give a voltage source which is L into IL of 0. In the present problem, IL of 0 is equal to 0 because 0 initial conditions. Vc of 0 is equal to 0. And what is C? C is 1 by 3 farads. And what is L? L is 1 Henry. So if I substitute all this, potential of this node is V naught of t. This is the reference node. V naught of t becomes what? V naught of t becomes V naught of S. V naught of t becomes V naught of S. If I substitute IL of 0 is equal to 0, Vc of 0 is equal to 0, then the circuit reduces to the form shown below. So this is plus minus 1 by S. This is 1 ohm. C is equal to 1 by 3 farads. So if you substitute C is equal to 1 by 3, this becomes 3 by S. Vc of 0 is 0 means voltage source becomes short. Voltage source is gone. This is 5 ohms. Okay. Substitute the value of L. L is 1 Henry. Therefore, this becomes just 1 into S. IL of 0 is 0 means voltage source becomes 0 means short. This is the reference node. This voltage is V naught of S. This voltage is V naught of S. We are required to find what is the voltage V naught of S. Then take its inverse Laplace transforms. That will give you V naught of t. I will take this mesh current as I1 of S. This mesh current as I2 of S. Please note that I have assumed the current directions to be leaving this node, so that where the current is entering, here you will have plus terminal, here you will have minus terminal. This aspect I have told while doing the theory. So here these two voltage sources, because of the initial conditions, do not matter because their values are 0. Whenever a voltage source is 0, it is represented by short circuit. Applying KVL applying KVL to mesh 1. Applying KVL to mesh 1 gives minus 1 by S plus 1 into I1 of S plus 3 by S into current in this branch is I1 of S minus I2 of S equal to 0. So this implies if it like terms you collect I1 of S, if you take common you get 1 plus 3 by S minus 3 by S into I2 of S is equal to 1 by S. So this implies I1 of S multiplied by S plus 3 divided by S minus 3 by S into I2 of S is equal to 1 by S. This I call equation 1. Applying KVL to mesh 2, applying KVL to mesh 2 gives, so it is 3 by S into I2 of S minus I1 of S is the voltage drop across this. My convention is voltage drops are treated as positive, voltage rises are treated as negative. This is the voltage drop across this element. When you are applying KVL to mesh 2, current in 3 by S will be I2 of S minus I1 of S. When you are applying KVL to mesh 1, current in the capacitor will be I1 of S minus I2 of S. Plus 5 into I2 of S plus S into I2 of S equal to 0. This implies minus 3 by S into I1 of S. If you take I2 of S common, you get 3 by S plus 5 plus S. Equal to 0. So this implies minus 3 by S into I1 of S plus I2 of S. If you take S LCM here, you get 3 plus 5S plus S square divided by S is equal to 0. Equation 2. Next what we will do is we will put equations 1 and 2 in matrix form. Putting equations 1 and 2 in matrix form. Putting equations 1 and 2 in matrix form gives S plus 3 by S minus 3 by S. First column we shall write the coefficients of I1 of S. Second column we shall write the coefficients of I2 of S. These are the coefficients of I1 of S and I2 of S in equation number 1. In equation number 2, these coefficients are minus 3 by S, S square plus 5S plus 3 divided by S multiplied by I1 of S, I2 of S is equal to 1 by S 0. So the idea is to find I2 of S. Then what is V naught of S? S multiplied by I2 of S. So in this we have to find I2 of S. We use Kramer's rule. What is delta? Delta is equal to determinant. S plus 3 minus 3 by S S square plus 5S plus 3 divided by S is delta. So this delta we shall simplify. S plus 3 divided by S. This implies delta is equal to this into this minus this into this. So it is S plus 3 divided by S multiplied by s square plus 5s plus 3 divided by s minus this into this minus 3 divided by s square. So if you take s square LCM and if you take s square LCM, you get s plus 3 into s square plus 5s plus 3 minus 3. So remove the brackets. So you get what? S cube plus 5s square, s cube plus 5s square plus 3s plus 3s square plus 15s plus 9 minus 3 divided by s square. Let me cross check. S cube plus 5s square plus 3s plus 3s square plus 15s plus 9 minus 3. So we get s cube plus 5 plus 3 is what? 8s square plus 18s. 9 minus 3 is 6 plus 6 divided by s square. This is delta. What is delta 2? Delta 2 is determinant. Replace the second column by right hand side. So you get s plus 3 divided by s minus 3 by s is the first column. Second column will replace the right hand side. 1 by s 0. Evaluate this determinant. This into this minus this into this. So you get 3 divided by s square. Therefore I2 of s is equal to delta 2 divided by delta. That means 3 by s square divided by delta. Delta means 1 by delta means s square divided by s cube plus 8s square plus 18s plus 6. 18s plus 6. So this becomes 3 divided by s cube plus 8s square plus 18s plus 6. 18s plus 6. So let me cross check the calculations. Okay, one small mistake has happened. This into this minus this into this means this is what? 9. So here this becomes 9. 9 and 9 gets cancelled. So this is what is I2 of s. So delta is this into this minus this into this. To find delta 2, replace second column by right hand side and evaluate the determinant, and that determinant is delta 2. I2 of s is equal to delta 2 divided by delta. So I made a small mistake. This into this is actually 9 by 3s square. 9 by s square and written as 3 by s square. Therefore, V naught of s is I2 of s into the impedance. Impedance is s. So what is I2 of s? I2 of s is 3 divided by s into s square plus 8s plus 18. S gets cancelled. So this is 3 divided by, let us complete the squares in the denominator polynomial. What is coefficient of s? Coefficient of s is 8. Divide that by 2, you get 4. Add the square of 4 and subtract the square of 4. This is done in order to complete the squares. S square plus 8s plus 16 minus 16 plus 18. So this implies V naught of s is equal to 3 divided by these three I can combine and write it as s plus 4 whole square plus 18 minus 16 is 2. 2 is nothing but root 2 whole square. I will multiply the numerator by root 2 and divide by root 2. So we get 3 by root 2 into root 2 divided by s plus 4 whole square plus root 2 whole square. Okay, recall Laplace inverse of b divided by s plus a whole square plus b square is equal to e to the power minus at into sine bt. We write t greater than equal to 0, or this can be written as e to the power minus at into sine bt into u of t. If you write u of t greater than equal to 0, you need not write. Because u of t is 1 for positive time, 0 for negative time. So this is for t greater than or equal to 0, or we write e to the power minus at sin bt into u of t. Hence v naught of t is equal to 3 by root 2 into e to the power minus 4t into sine root 2 into t. Normally we follow the answer in this format. So I write here u of t. So this is the expression for v naught of t. Okay. We shall go to next problem. So this is the circuit plus minus 10 into e to the power minus t into u of t is the voltage source. Right, the problem is for the circuit shown, find v naught of t. Find v naught of t. Assume v naught of 0 is equal to 5 ohms. This is the problem, and this is the circuit. So if you take this as reference node, potential of this node is v naught of t. Okay? V naught of t. The solution, the Laplace transform network. The Laplace transform network is as shown below. The Laplace transform network is as shown below. Please note, Laplace transform of e power minus at into u of t is equal to 1 by s plus a. Laplace transform of impulse function is 1. So this circuit, now what happens? Laplace transform of this is what? 10 divided by s plus 1. Resistor is unaffected, so it remains as 10 ohms only. Even this resistor remains unaffected, it remains as 10 ohms only. This capacitor becomes what? 1 by Cs in series with a voltage source. The voltage source is, correct, V naught of 0 divided by, yes, V naught of 0 is the voltage across the capacitor. And Laplace transform of this impulse is 1, therefore you get 2. This is the reference node whose voltage is 0. This node I will call node 1, whose potential is V naught of S. So here C is equal to 0.1 farads. V naught of 0 is equal to 5 volts. So 1 by Cs means 1 by 0.1 is 10, this becomes 10 by S. V naught of 0 by S becomes 5 divided by S. If you assume the current to be leaving node 1, then the current is entering the plus terminal. You have to be very careful about the polarities of this initial voltage source. Applying KCL at node 1, gives, correct, potential here also is V naught of S. What is difference in potential across 10 ohms? It is V naught of S minus 10 divided by S plus 1 divided by 10 is the current through this 10 ohms, and the current is leaving node 1. Current in this 10 ohms is V naught of S minus 0 divided by 10. What is the current in this capacitor? What is the potential here? V naught of S. What is the potential here? It is V naught of 0 divided by S. So we write plus V naught of S minus V naught of 0 divided by S. Whole thing divided by 10 by S. Difference in potential divided by the impedance. The impedance is 10 by S. What is the unit of capacitor? Farads. What is unit of 1 by Cs? Ohms. What is the unit of L? Henries. What is the unit of Ls? Ohms. So L into S and 1 by Cs are nothing but impedances. Okay. Is equal to current entering. Current entering is 2. The terms on the left hand side indicate the currents leaving node 1. The term on the right side indicates the current entering node 1. V naught of S by S is what? V naught of S by S is 5 divided by S. Now collect all V naught of S terms together. So this implies V naught of S, if you take common, you get 1 by 10 plus 1 by 10 plus, from here what you get? From here you get V naught of S, if you take common, you get S by 10 correct, and constant terms that are free from V naught of S, I take it to right side, is equal to 2 plus what happens to this term? 5 by S into S by 10. And from here we get plus 1 by S plus 1. So this implies V naught of S is equal to 2, this is what? 2 by 10 plus S by 10 is equal to 2 plus 5 divided by 2 plus 5 divided by this S gets cancelled, 5 divided by 10 is half plus 1 by S plus 1. So this implies V naught of S into S plus 2 divided by 10 is equal to, this is 5 by 2 plus 1 by S plus 1. So cross multiply, if you cross multiply you get V naught of S is equal to 10 divided by S plus 2 into 5 by 2 plus 1 by S plus 1. So this is nothing but 50 divided by s into s plus 2 plus, I made a mistake, this is 5 by 2. So this becomes now 25 divided by s plus 2 plus 10 divided by s plus 1 into s plus 2. This implies V naught of s is equal to, this implies V naught of s is equal to, if you take s plus 1 into s plus 2 as LCM, then you get 25 into s plus 1 plus 10. So this becomes 25s plus 35 divided by s plus 1 into s plus 2. Using the theory of partial fraction expansion, we can write V naught of s is equal to k1 divided by s plus 1 plus k2 divided by s plus 2 is equal to what? We can write V naught of s is equal to 25s plus 35 divided by s plus 1 into s plus 2 equal to this, where k1 and k2 are the constants associated with partial fraction expansion. So this implies k1 into s plus 2 plus k2 into s plus 1 is equal to 25s plus 35. We have got two constants k1 and k2, we have to evaluate them. You can put any two arbitrary values of s, you will get two simultaneous equations, solve them. Otherwise, do like this. Put s is equal to minus 2. If you put s is equal to minus 2, this will become 0. Then what happens? Then k2 into minus 2 plus 1 is equal to 25 into minus 2 plus 35. This implies minus k2 is equal to minus 15 plus 35 is equal to minus 15. This implies k2 is equal to 15. Second is, put s is equal to minus 1. If you put s is equal to minus 1, this will become 0. So what you get? You get k1 into minus 1 plus 2 is equal to plus minus 1 plus 2 is equal to 25 into minus 1 plus 35. So this implies k1 is equal to 10. So like this, the values of k1 and k2 are found. Let us now substitute the values of k1 and k2 in this equation. Hence V naught of s is equal to 10 divided by s plus 1 plus 15 divided by s plus 2. Taking inverse Laplace transforms, we get V naught of t is equal to 10 into e power minus t into u of t plus 15 into e power minus 2t into u of t. This is the answer. All these problems, study well, they will appear in your test number 3. Similar problems may not be exactly same. Some numerical changes would be there, but topology of the circuit will not change. Next problem is okay. This is the problem. The switch is in position A and position A, and steady state is reached. And steady state is reached. The switch is moved. The switch is moved. The switch is moved from position A, from position A to position B, position A to position B at t is equal to 0. Find I of t. This is the problem, very commonly asked problem. The switch is in position A and steady state is reached. The switch is moved from position A to position B at t equal to 0. Find I of t. Find I of t. Solution. I'll put a small table. This is time. This is position of the switch. Position of the switch. For t less than or equal to 0 minus, for t less than or equal to 0 minus, the switch is in position A. For t greater than or equal to 0 plus, the switch is in position B. And switch is moved in 0 time from position A to position B. For t less than or equal to 0 minus, switch is in position A. For t greater than or equal to 0 plus, switch is in position B. All this your teacher has told you while teaching initial conditions. The circuit diagram, right? Under steady state condition, first let me say, under steady state condition, under steady state condition, inductor acts as a short circuit. Inductor acts as a short circuit. Hence at t is equal to 0 minus, comma, the circuit is as shown. The circuit is as shown below. This is 2 amperes. The switch is in position A. The switch is in position A. Resistor is unaffected by switching condition. Inductor becomes short. The current to the inductor is I of 0 minus. So what is I of 0 minus? I of 0 minus is equal to 2 amperes. This 2 amperes is flowing through the short circuit. Since current through an inductor cannot change suddenly. Since current through an inductor cannot change suddenly, I of 0 plus is equal to I of 0 minus is equal to 2 amperes. And this is denoted simply as I of 0. I of 0 means it could be I of 0 plus or I of 0 minus. So from position A, we have found what is the initial current through the inductor. The circuit diagram for t greater or equal to 0 plus is as shown below. This is the voltage source, which is 4 times u of t. The switch is now in position. The switch is now in position B. This is position B. This is the switch. 2 ohms. This is 1 Henry. Current to the inductor is I of t. What is the initial current? Initial current I of 0 is equal to 2 amperes. This is the circuit diagram. The Laplace Transform network. The Laplace Transform network is as shown below. Laplace transform of 4 into u of t is 4 by s. Resistor is unaffected by the transformation. Inductor will become what? L into s, followed by a voltage source which is L into I of 0. The current I of s must enter the minus terminal of the voltage source. L into I of 0. What is L? L is 1 Henry. I of 0 is 2. So L into I of 0 is 2 volts. Is L into S. Unit of Ls is what? Ohms. And what is L into S? L into S simply S. Applying KVL, we get minus 4 by S. Voltage rise, I treat it as negative. Plus 2 into I of S. Plus S into I of S. Minus 2 is equal to 0. So this in turn implies, if you take I of S common, you get S plus 2 is equal to 4 by S plus 2. So this implies I of S is equal to 4 by S into S plus 2 plus 2 divided by S plus 2. If you take S into S plus 2 as LCM, you get 4 plus 2S. So using theory of partial fractions, I write this as K1 by S plus K2 divided by S plus 2, where K1 and K2 are the constants associated with partial fraction expansion. Where K1 and K2 are the constants, K1 and K2 are the constants associated with partial fraction expansion. So we have K1 into S plus 2 plus K2 into S is equal to 4 plus 2S. You can put any two arbitrary values of S because there are two unknowns K1 and K2. I shall put S is equal to minus 2. Then this implies minus 2 K2 is equal to 4 plus 2 into minus 2. So this is 0. This implies K2 is equal to 0. Then I put S is equal to 0. If I put S is equal to 0, this term will become 0. No need to put minus 2 and 0. You can put even S is equal to 1, S is equal to 2. You will get two simultaneous equations, solve them. If you put S is equal to 0, you get 2K1 is equal to 4. This implies K1 is equal to 2. Substitute the values of K1 and K2 over here. Hence, I of S is equal to 2 divided by S plus 0. This implies what is I of t? I of t is equal to 2 times U of t. Because Laplace inverse of 1 by S is U of t. This is the answer. I'll go to the next problem. Okay. This is IL of 0 is equal to minus 1 ampere. V naught of 0 is equal to 5 volts. This is the problem. Find V naught of t. Find V naught of t. Solution. The Laplace transform network. The Laplace transform network is as shown below. The Laplace transform network is as shown below. So what is Laplace transform of U of t? 1 by S, 10 by S. Resistor is unaffected by the transformation. This is 10 by 3 ohms. Inductor will become what? L into S in series with a voltage source L into IL of 0. L into S is what? L is 5, so it becomes 5S. L into IL of 0 is minus 1, so this becomes minus 5 volts. L is 5, IL of 0 is minus 1. Potential of this node is V naught of t. So please note the current IL of S should enter the minus terminal of this voltage source. Capacitor will become what? 1 by Cs in series with a voltage source V naught of 0 divided by S. This current in this branch has to enter the plus terminal of this voltage source. 1 by Cs means this becomes 10 by S. V naught of 0 is 5, therefore it becomes 5 by S. Let us say this is the reference node whose potential is 0. This I will call node 1. Potential of node 1 is V naught of S. Very simple. Now we will applying KCL at node 1. Applying KCL at node 1, we get what is current in this 10 by 3? Here the potential is V naught of S. Here the potential is 10 by S. Difference in potential divided by the resistance value. So you get V naught of S minus 10 by S is difference in potential divided by 10 by 3. What is the potential here? Potential here is V naught of S. What is the potential here? It is L into IL of 0. So it is plus V naught of S minus L into minus of minus. The potential here is minus L into IL of 0. So it is minus of minus L into IL of 0 divided by the impedance which is 5S. What is difference? What is the potential here? Potential here is V naught of 0 by S. Difference in potential is what? It is V naught of S minus V naught of 0 divided by S, the difference in potential, divided by the impedance. Impedance is 10 by S. This must be equal to 0. No current is entering. Therefore, right hand side is 0. All the currents are leaving node 1. So this implies 3 by 10 into V naught of S minus 10 by S plus V naught of S minus into minus plus. What is L into L of 0? L into L of 0 is minus 5. So it is minus 5 divided by 5S plus V naught of S minus what is this 10 by S becomes S by 10 once it goes to numerator. V naught of S minus what is V naught of S by S? It is 5 by S equal to 0. So this implies you take V naught of S common. If you take V naught of S common, you get 3 by 10 plus 1 by 5S plus S by 10 is equal to 10 cancel. This time if it goes to the right side it becomes 3 by S. From here you get minus 1 by S, which when goes to right side becomes 1 by S. Here SS cancels. Minus 5 by 10 means minus half. When it goes to right side it becomes half. This is 5 by S. Okay. So this implies V naught of S. If you take here 50 S as 10 into 5 S as LCM, if you take 10 into 5 S as LCM, this becomes 3 into 5 S is 15 S plus 10 plus S into 5S means 5S square. Here if you take this becomes 4 by S plus half, which is if you take 2S as LCM, this becomes 8 plus 8 plus S. 8 plus S. So from here this implies 15S plus 10 plus 5S. Correct. This implies V naught of S into 5 and rearrange 5S square plus 15S plus 10 divided by 50S is equal to S plus 8 divided by 2S. This in turn implies V naught of S is equal to cross multiply. You take this term to right side, you get 50S divided by 5S square plus 15S plus 10 multiplied by S plus 8 divided by 2S. So 50S by 2S is what? 50S by 2S is 25. 25 into S plus 8. You take 5 common here, you get S square plus 3S plus 2 So this is 5 into s plus 8 divided by, this is nothing but s plus 1 into s plus 2. 5 into s plus 8, 5 into s plus 8, divide 5 into s plus 8 divided by s plus 1 into s plus 2. So using theory of partial fractions, we can write this as k1 divided by s plus 1 plus k2 divided by s plus 2, where k1 and k2 are the constants, associated, k1 and k2 are the constants associated with partial fraction expansion. PFE is partial fraction expansion. Let us now proceed to find k1 and k2. k1 into s plus 2 plus k2 into s plus 1 is equal to 5 into s plus 8. I will put s is equal to minus 2. This implies 0 plus k2 into minus 2 plus 1 is equal to 5 into minus 2 plus 8. This implies minus k2 is equal to, this is 30. This implies k2 is equal to minus 30. This implies k2 is equal to minus 30. Then I will put s is equal to minus 1. If you put s is equal to minus 1, you get k1 into minus 1 plus 2 plus 0 is equal to 5 into minus 1 plus 8. So this implies k1 is equal to 35. Substitute the values of k1 and k2 over here. That gives us V naught of s is equal to k1 is substitute 35 divided by s plus 1, k2 is minus 30, so we get minus 30 by s plus 2. Therefore, V naught of t is equal to 35 into e to the power minus t into u of t minus 30 into e to the power minus 2t into u of t. Please note, Laplace inverse of 1 over s plus a is equal to e to the power minus at into u of t. Note. Thank you. This much you study for the test. Okay. So please go through complete two-port parameters and what I have done in Laplace transformation till here. Thank you.